Good afternoon, everyone, and welcome to today's webinar on nature-based solutions for transportation systems. My name is Jason Beckfield. I'm a professor of sociology at Harvard University, and it's my great pleasure to be working with several colleagues at the Harvard Climate Action Accelerator on this webinar series that was really inspired by the success of the US DOT's Climate Change Center. But as everyone knows, under the current circumstances, I want to make this perfectly clear. This is a Harvard initiative that I'm very happy to be carrying the ball forward on. So let me share my screen. Wouldn't mind giving me a second. Okay, so I'd like to start by just saying a few words to set the table for us a little bit. The Climate Action Accelerator is an initiative of the Salata Institute for Climate and Sustainability at Harvard. And the idea of it, the fundamental mission of it, is really to connect intellectual resources, research resources, data, from inside Harvard with folks outside Harvard who are actually doing the hard work of carrying out climate change solutions. And so the Climate Action Accelerator is a wonderful home for this webinar series because this is exactly what we're trying to do. We're trying to diffuse research findings as well as field experiments on what it actually means to do work on nature-based solutions for climate change in transportation systems. And I want to just acknowledge my colleagues at the CAA, Christine and Beverly and Thais and Laura on this project. I really appreciate their support. I also want to mention that I'm working as a faculty member in the research cluster on strengthening communities. That's more of a scholarly effort, but it too has an outside in and inside out kind of focus in that what we try to do in that research cluster is to understand the ways in which social dynamics are important for climate change solutions. We look primarily at energy transitions, including, citing debates around energy transmission, energy storage, energy generation. But of course, there are important relationships between the supply side and the demand side for energy. And so transportation system changes are as interesting to me as I think about how social factors matter for climate change solutions. And so we have a really exciting panel today. I'm so grateful to folks for scrambling and squeezing us in to make this webinar possible. I'll just introduce everyone very briefly, and then we'll turn to folks in turn after I take a minute to offer some opening perspectives from social science. So first we'll hear from Josh DeFlorio, Sarah Colasurdo, and Angela Wong from the Port Authority of New York and New Jersey. They have a very interesting new report out on climate vulnerabilities and approaches to addressing those climate vulnerabilities in the transportation system there. We'll then pivot to Garrett Altmann, who's a Western Restoration Program Manager with the Environmental Policy Innovation Center. And then we'll finish with Courtney Schupp, who's a regional coastal geologist with the National Park Service in the Southeast Regional Office. And I want to mention at the outset here, I want to encourage you all to stay tuned for a new website at the Salata Institute for Climate and Sustainability. We are currently working to make many of the resources now that are still online, but that are a little bit difficult to find. Some of them are in Rosa P., the National Transportation Library. Some of them are on the Harvard Dataverse website. Some of them are in other places. And we are going to work to create a new website to make it easier to find these taxpayer-funded and formerly publicly available online resources for transportation professionals. One of the tools, for instance, is the Vision Eval tool. of the DOT. Another set of documents that people have often used is the adaptation planning documents. The URL is linked here. And then, one of the big accomplishments, I think, of the US DOT Climate Change Center is the Climate Strategies That Work document, or the website, really, that's full of resources. We'll be incorporating that too in this website that'll be more easy to use. The QR code at the bottom right links you to the Harvard Dataverse website, which is an effort of the research cluster on strengthening communities to preserve many of the formerly publicly available data and reports and helpful tools from the DOT, as well as other federal agencies. So, why is a social scientist interested in nature-based solutions? I want to begin by offering what I see are, some helpful tools from, my field, and tools from behavioral science more broadly for doing projects that involve nature-based solutions. And here, I have a very encompassing sense of what nature-based solutions are. I think Courtney is going to give us a much more expert, and refined definition in her presentation. But at the outset, sociologically, a nature-based solution is a change in the way people relate to nature. And one of the toolkits from my field involves identifying how people relate to nature. People, in the indigenous tradition, for instance, the relationship between human society and nature is one of kinship. There are also ecological relations of dependence. People also use nature in a variety of ways for recreation, for instance, for transportation, and many organizations adopt a preservation relationship with nature. And so I think in doing a nature-based solution project, you encounter very many challenges, of course, and I think to encapsulate a large research literature, a set of challenges that is often underlying the problems that one faces on the ground have to do with differences among people in how they relate to nature. And so understanding those relationships, I think, is a helpful toolkit. One of the ways to do that is photo voice research, which is a very low cost, qualitative approach to understanding nature, human society relationships. And I also just wanted to note that one of the things that nature-based solutions can do, depending on their scale, depending on the place that they are, is they can provide social infrastructure. Basically places where people can hang out. That turns out to be something, of course, that is very important to people. And so there's a book that I would recommend there called Palaces for the People. Secondly, one of the things we've been doing in the Strengthening Communities research cluster is to understand contemporary best practices in community engagement. And one of the findings from that work is that community engagement tends to be more successful if community members are approached as partners in problem solving at a very early stage of projects. I imagine this audience is probably quite familiar with community engagement processes that are more about getting buy-in, or checking a box, or complying with a legally required process. And what we're finding in our work is that coming to community members and saying, we're going to be doing this project. We know you live here. We know you have an interest in this place. We have a question about what it is that we're doing, citing, facility X, Y, and Z, for instance. How would you think about that? Can you help us with this? That kind of approach, I think, tends to work a lot better. There's also a literature on trust that I want to make a quick reference to. There's a huge social science literature on how trust is built, how trust breaks down, and how trust is repaired. One of the important insights from that field is that the process of building trust is different from the process of repairing distrust, because distrust is not quite the same thing. It's just the opposite of trust. And Karen Cook's excellent book Trust in Society gets deeper into this. For a planning oriented approach to community engagement, I would certainly recommend Tyler Harrison's hyperlocal engagement approach. This is engagement projects that's attuned to the neighborhood level, right, the very local level. But if I was to tell you one thing about community engagement that I've learned from the work that we've been doing in the Strengthening Communities cluster, is that the earlier you can do it, the better it is. And the more open you can be about what kind of engagement you're actually able to do, the more productive it is. You don't want to promise things that you can't deliver. People get pretty frustrated by that. There's a spectrum of community engagement that runs, all the way from power sharing and incorporation and decision making at one end to, really just communication about a project that's happening, and a full spectrum of those in between. And so expectation setting about where you are in that spectrum at an early stage turns out to be very important. Okay, that is more than enough from me. Let me turn to my expert panelists here, and I'll ask Josh and Sarah and Angela to share the stage.
Excellent. Are folks seeing let's see, let me try to put this in presentation mode. Try again here. Okay, first of all, can everybody hear me, and can everybody see the presentation in the proper mode? Okay, that's half the battle right there. Thanks so much, Jason and Christine and other members of the Salata Institute. It's an honor to be here today. My colleagues, Sarah Colasurdo and Angela Wong, and I are thrilled to present to you the hot off the presses climate risk assessment that we have performed. I will say, because the Port Authority is a rather strange animal, the nation's first bi-state authority dedicated to transportation, the mission of the Port Authority is to keep the region moving. Let me spend just a moment talking about the Port Authority and its unique facilities. So we are very multimodal. We include aviation assets, including the big three aviation facilities in our region: John F. Kennedy International Airport, LaGuardia, and Newark, as well as two smaller airports. We have the tunnels, bridges, and terminals that connect New York and New Jersey. We have, of course, you can have a port authority without port facilities. So we have the second largest port complex in the United States. We have a small but mighty urban rail asset called Port Authority Trans-Hudson, or PATH, and the iconic 16-acre World Trade Center campus as well. A quick overview, just high level, of the climate risk assessment before I turn it over to my colleagues for more detailed explanation. The climate risk assessment is intended to be a proactive effort to use engineering grade tools and data married with the best available regional climate science to identify and to mitigate critical climate related risks at all of our facilities. The overarching purpose, really the only purpose for performing this assessment, was to inform prioritization of resilience projects in our forthcoming 2026 to 2035 capital plan. We are at the very sunset of our current 10-year capital plan, which has facilitated $37 billion in infrastructure investment. And with the sunset of one capital plan comes the rise of the next capital plan, which for the first time ever will include resilience as a key area of priority. As you'll hear, the process entailed deep explorations into our at-risk critical assets. And this included Port Authority assets, of course, but also we have strong tenant relationships, particularly at our airports and ports. And we wanted to reflect the value and potentially the value at risk of those assets. We also looked at external connections outside the gate connections to the Port Authority, including roadways, utilities, fueling, communications, so on and so forth. We looked at and quantified as best we could the direct and indirect consequences of inaction. I think it's particularly in the exploration of indirect consequences that we broke new ground. Ultimately, this was to try to determine what is the value proposition for mitigation? How much can we reasonably, responsibly spend on climate risk mitigation to mitigate those highest priority risks? And ultimately, at the end of the day, as I mentioned, this entire exercise, the reason and purpose for performing this very muscular assessment, time-intensive and costly assessment, was to inform the strategic priorities of our very large 10-year capital plan. The time period addressed here was from present day through the end of the century to 2100. And the 4 key climate stressors that we evaluated are sea level rise, storm surge, obviously exacerbated by projected future sea level rise, intense precipitation, and extreme heat. And with that short and sweet introduction, I will turn it over to the program manager for the climate risk assessment, my colleague, Sarah Colasurdo.
Thank you so much for that introduction, Josh. And let's see here. First, I'm going to walk through the risk calculation approach that we used for the climate risk assessment and a little bit about the climate risk assessment methodology before Angela will get into some of our nature-based solutions. So the climate risk assessment calculates risk to critical assets based on the probability of an event occurring and its consequences. And usually this risk calculation includes the probability of direct damage to an asset and then the cost to restore that asset. And we took that risk calculation a step further by incorporating not just the probability of direct damage to that asset, but the probability of indirect impacts as a result of cascading failures of upstream and downstream assets. So for the consequences of failure, in addition to the restoration costs of the asset, we used downtime to estimate the negative financial effects on the Port Authority's revenue and on the regional economy. And Josh, if you could click through like 6 times or so. All right. So to illustrate this, a container crane is a tenant asset critical to our mission for the movement of goods. And upstream is a tenant-owned transformer fed by a Port Authority-owned substation. And then our substation is only in operation if the utility substation that's upstream of us is operating. So these are all links in the dependency chain on which this essential function depends. Josh, can you click through again? So even if we take measures to mitigate our substation, we need to be clear-eyed about the risk to other assets on which our revenue and the region's economy depend, and support our partners in protecting their assets as well. Next. I'll walk through a bit of an overview of the climate risk assessment process. It consists of 3 phases. First, we identified the assets of highest criticality and consequence, and where appropriate, we linked them into systems of assets based on dependencies. And then in phase 2, we quantified the most at-risk critical assets based on direct and indirect impacts of different climate hazards by calculating risk scores for each asset that reflect relative risk per hazard. And then in phase 3, the highest asset risks served as the basis for developing risk mitigation projects. And the outputs of the climate risk assessment are already being integrated into several business processes at the Port Authority, including capital planning and enterprise asset management. Next. Diving into the first phase a bit more, we spent a great deal of time connecting assets into systems through critical dependencies and redundancies to understand cascading impacts across systems. So we custom built an asset management decision support tool to map the asset network, which allowed us to propagate consequences across the network. And we utilized the Port Authority's enterprise asset management data as the starting point for asset data collection. And in addition to engineered assets such as electrical and mechanical assets, our enterprise asset management system contains classifications for assets, including trees and shrubs and other vegetation. Next. In the second phase, we overlaid hazards onto the asset data And illustrated here is one example. This is a time series of the 1 year through the 1,000 year precipitation event under today's sea level rise. And at each facility, we modeled coastal flooding and stormwater flooding across 10 storm intensities and 6 sea level rise scenarios, representing conditions today through 2100. Various data sources that we used to inform flood dynamics and potential mitigation measures included digital elevation models, the engineered drainage system, as well as the U.S. Fish and Wildlife National Wetlands Inventory, the NRCS soil classification data, and parcel data with percent impervious coverage. Next. Finally, for the third phase, here's an example of how in the climate risk assessment, we explored mitigation measures. As we narrowed down options for each site into just one preferred alternative, we factored in various metrics, including benefit to cost ratios, facility input, first costs versus maintenance costs, and opportunities for nature-based solutions. Nature-based risk mitigation measures were informed by the Port Authority's Green Infrastructure Design Manual, which we'll touch on later in this presentation also. Next. And throughout the entire process, input from the experts on the ground was really invaluable. The CRA was intended to be an inclusive effort to try and understand the broader ecosystem of how our facilities function and the interdependent consequences of climate impacts, which is why we engaged tenants and operating partners and utilities to understand the vulnerabilities of their critical assets as well. So I'll turn it over to Angela Wong to discuss nature-based mitigation measures.
Thank you. Can you hear me? Can you hear me now?
We can.
Okay, great. In this section, we'll provide 3 examples of nature-based mitigation measures that we investigated in the CRA. And as Josh and Sarah mentioned, a key outcome of the CRA is to have the prioritized climate risk mitigation measures incorporated into the capital plan. And the capital planning process is currently ongoing, so we are working to ensure as many projects developed through the CRA are prioritized in the capital plan. So in this first example of a living shoreline, the proposed project would help protect a roadway that is at risk to erosion and wave damage, and the living shoreline would be designed to reduce wave energy and create habitat that would help reduce erosion and flood risk due to wave action. In order to stabilize the shoreline and enhance the ecosystem, the proposed project would incorporate planted wetlands and other planted areas, and the mitigation strategy would also install precast concrete sills for immediate protection to the wetlands and planted areas. We would also install submerged habitat blocks to dissipate the wave energy, and also place stone groins to help dissipate wave energy, which would minimize the shoreline impact. And some of the empirical calculations as part of the conceptual design process indicated that there would be significant wave height reduction from this nature-based mitigation strategy. An estimated 100-year wave height of approximately 6 feet would be reduced to just under 2 feet when the wave is transmitted through the stone groins, and there would also be a reduction in wave height when the wave is transmitted through a living shoreline. Overall, reducing the wave height would reduce the energy in the wave, and waves with less energy are less erosive and destructive. And in the next slide, as part of the conceptual design process, the team also evaluated different plant mixes and planting schedule with different quantities for each of the marsh zone, including the upland, highland, high marsh, the transitional marsh, and low marsh. And in the second example of a mitigation project, at another facility, the team evaluated a nature-based solution to raise the elevation of the existing adjacent salt marshes in order to mitigate tidal flooding due to sea level rise. So this mitigation measure intends to prevent regular tidal flooding as the sea levels rise, as well as to help absorb some of the wave energy during low intensity surge events. As we saw in the previous example, marshes are beneficial in terms of providing natural buffers against storms by attenuating wave heights. But given the rates of sea level rise in the New York and New Jersey region, it's unlikely that the salt marshes could adapt through natural accretion. And in the case that salt marshes do maintain their absolute elevation currently as sea levels rise, they would lose their ability to support vegetation because many of the wetland plant species can't survive once fully submerged. So sustaining these tidally influenced wetland habitats would require actively managing, or in this case, raising the elevations. And here we're proposing we evaluated the mitigation to place thin layers of sediment over time. And so we would place thin layers of sediment on top of the existing salt marshes to help elevate them and continue to do so in time intervals determined by ongoing monitoring of the marsh elevation. And as part of this project, we also investigated reuse of sediments from dredge materials in nearby waterways rather than disposal of the dredge materials. And the third example of a nature-based mitigation solution is a green roof. Green roofs tend to help mitigate stormwater, and in this case, we evaluated application of a green roof to help mitigate heat risk. And some research indicates that green roofs could reduce the indoor air temperatures between 2.7 degrees Fahrenheit up to 15 degrees Fahrenheit. And this project came about because we're looking at ways to mitigate the risk of failure of electrical equipment located inside a building from extreme heat. And a green roof would reduce the heating and cooling load, as well as mitigate the heat gain. And during an outage, the temperature inside the building would be mitigated, which would reduce the load on our backup power that's needed. And design of this green roof builds on our Port Authority Green Infrastructure Design Manual, which we'll discuss next. Josh, you're on mute.
Can you hear me now? Okay, I was double muted. Common problem. Okay, so thanks, Sarah. Thanks, Angela. We mentioned the Green Infrastructure Design Manual, and we encourage employment of nature-based solutions as part of the design process as well. So you heard about how it featured in the climate risk assessment process and the development of scoping level mitigation measures, but it has been an objective of ours since we issued this standard in January of 2021 to ensure that pipes and plants are working together to help manage our stormwater challenges, both from a resilience standpoint and from a sustainability standpoint. So we worked collaboratively with our landscape architecture and our civil units in-house to develop the GIDM, which is available on our public website. We'll send you a link afterward. This slide makes me feel calm, so we like to show it, the beautiful plant palette that we developed as part of this standard. And we are implementing it to provide primarily customized guidance to designers at our facilities, as you might imagine, given the specialized nature and the industrial nature oftentimes of these facilities. Different types or different interpretations of green infrastructure standards are often needed. We wanted to ensure that our designers were on solid ground when seeking to employ green infrastructure and nature-based solutions at our unique facilities. Oh, I seem to have lost the ability to forward. Sorry for the technical difficulties. Okay, great. In concert with the Green Infrastructure Design Manual, I clearly shouldn't have been the one doing the slide driving here. In concert with the Green Infrastructure Design Manual, we've also developed a handful of screening tools, primarily to clarify the value proposition and the needs of green infrastructure early in the design process. So I'll be short and sweet with these, but this is a GIS screening tool that we developed. It really, oops, and here it goes, just advancing on its own. So it's what we did was we collected layers, many of them publicly available, many of them specific to the Port Authority, to try to clarify the value proposition of green infrastructure at our facilities really early on, so that the design teams could either embrace green infrastructure or discard it as an option. It doesn't work in every instance. Oftentimes we can find solutions that marry traditional gray infrastructure with green infrastructure solutions. So this was really to try to get to the heart of the matter as quickly as possible. We also introduced a green infrastructure calculator, which is also a screening tool. This is a simple Excel-based resource, and it's intended, again, to quickly zoom in on the GI options that have the greatest potential and to eliminate unworkable options. And this is not intended to be a design resource per se, but a resource for designers at the very beginning of a project to really hone in on what's likely to be the most applicable and productive solutions. So ending where we began with the climate risk assessment, we've labeled this explicitly the inaugural climate risk assessment. We expect fully to repeat and refresh this process every capital plan cycle. As I mentioned, we have a 10-year capital plan cycle, so at least 5 years prior to the sunset of the capital plan cycle, we're going to perform another climate risk assessment. We expect to do sort of half-step refreshes every 2 years or so. This is commensurate with what we do with other aspects of our capital plan, like state of good repair. We have just wrapped up the climate risk assessment. As you've heard, we have developed the climate risk reduction plans. We are at the cusp of having those prioritized into our capital plan, which will be publicly released later this year. And then we will shift to the important work of implementation, monitoring, and repeating the cycle. I will say that this graphic is also included in the National Climate Assessment 5, National Climate Assessment 6, may God rest its soul. But we contributed this as a resource that any of you can access through the 5th National Climate Assessment. So that being said, to close out, it's hard to summarize 4 years of intensive work in just 20 minutes, and hopefully we've hit the mark on time. So if there are questions that we don't get to in the course of this webinar, please do reach out to us. Here's our contact information, resilience@panyj.gov. You can also find a high-level climate risk assessment overview on our public website, and the Green Infrastructure Design Manual is a public resource as well. We'll send these to the webinar organizers to blast out to the group. And with that, I thank you for your time, and we all look forward to your questions later in the webinar.
Thank you very much, Josh and Angela and Sarah, for the marvelous presentation. Mostly, I want to get us ready to pivot to Garrett Altmann, but I meant to say at the outset of the session that we would have time for question and answer at the end. So I would certainly like to invite you to participate in the Q&A. But there were a couple questions that I think are actually related and that are pretty targeted that I thought I might just pose to the Port Authority team really quickly before we pivot over to Garrett. One has to do with the weight of green roof infrastructure. And I wonder if you have information in the design manual about retrofits, or is it limited to new construction? And it also strikes me that your material on green roof could be very helpful for inland nature-based solutions. I mean, given your geography, it makes a lot of sense that the emphasis should be on coastal hazards. But I wonder if you think about it as promising on the inland side.
Maybe I'll start with can you hear me?
Yep.
All right, always good to make sure. Maybe I'll start with the second question and certainly invite my colleagues to jump in as well. But we also, in addition to coastal stressors, we also looked at intense precipitation. We looked at extreme heat. So those risks and those solution sets are applicable to inland geographies for sure. Obviously, given our history, particularly with Hurricane Sandy and our situation as a effectively coastally adjacent authority, sea level rise and storm surge has historically been our emphasis, but we have recognized the importance of widening the aperture to include precipitation and heat. In terms of the Green Infrastructure Design Manual and the question about green roofs specifically, it is, I will say, transparently easier to implement a green roof on a new facility where the structural proposition is clear. We have many historical, let's say, legacy buildings, to be kind to them. And sometimes the structural loading proposition, the ability basically of the load-bearing walls to take the additional weight, is a question that comes up. I tend to think for an extensive rather than an intensive green roof system that's a bit of a red herring. But it is more challenging to proceed with a green with a green roof, or sometimes other green infrastructure solutions for legacy assets.
Thank you, Josh. Really appreciate you being able to jump in on that. Let me turn it over now to Garrett Altmann. Garrett, as I mentioned, is the Western Restoration Program Manager at the Environmental Policy Innovation Center. And I know everyone is squeezing us in today, and Garrett, I think, is really getting the gold star for that, given given how he's shoehorning us in from where he is in California. So thank you, Garrett. Please take it away.
Thank you, Jason. I appreciate the opportunity to be here. And I'm attending a conference in Santa Cruz, California, but I'm happy to step away to participate in this exercise. I'm very passionate about nature-based solutions. I've been working with them for close to 10 years now, before we even called them nature-based solutions. And I'm happy to share some of my experiences here, and hopefully can translate to some of your projects across the country. So today I'll be speaking about NBS, or nature-based solutions for roadway crossings, and presenting a tribal case study from New Mexico in a watershed that was severely impacted by both wildfire and post-fire flooding. Quickly discuss what I do at EPIC, why we are focused on stream crossings, and I'll proceed with the case study, some of the best practices we've learned, and provide an opportunity for some questions at the end. So at EPIC, our mission is to build spectacular policies that deliver spectacular improvements in the speed of environmental and public progress. We believe that nature-based solutions presents an ideal strategy to conserve wildlife, restore natural places, and provide a cost-effective approach to deliver people and nature with the clean water they need to thrive. And my slides aren't advancing suddenly. Here we go. So why roadway crossings? I tend to focus primarily on roadway crossings in the context of fish passage and reconnecting habitat, particularly for our coastal and anadromous salmon and steelhead species in the Western US. But there are national efforts on the Gulf Coast and East Coast as well as international efforts in other places. But the reason we focus on these is they often limit habitat, biodiversity, and climate resilience. They impact sediment transport and can frequently be prone to flooding and essentially blowing out from larger events and significant infrastructure damage, as we'll see. In this case study here in northern New Mexico, this took place within a federally recognized tribe and within their tribal reserved lands. The Santa Clara Pueblo, it consists of about 1,500 tribal members. They have a tribal reservation of approximately 90 square miles of land. And for folks who aren't familiar with the Pueblo system in New Mexico versus Indian reservations, Pueblo communities are situated on their ancestral lands versus being relocated to a reservation, as many of our Native Americans have been. Physically, Santa Clara Reservation is really highlighted by the Santa Clara Creek watershed and the Santa Clara Canyon. This area is central to Pueblo life, both spiritually and physically. This 32,000 acre watershed is just over half of the reservation, consists of about 50 square miles, has a very high elevation gradient from just above 5,000 feet on the Rio Grande to close to 11,000 feet at the highest peak on the north end of the canyon. Within that, we have a 23-mile perennial stream that traverses several bioclimatic zones and ecosystems. And within that, we have a 28-mile rural road that transects this watershed. In addition to that, infrastructure-wise, historically, the area had 4 recreational fishing ponds that were relied upon for not just recreation, but as the tribe's primary economic revenue source up until the year 2000. Unfortunately, as we're seeing throughout, well, before we get to that, just a picture of the upper watershed here. pre-fire. You can see intact mixed conifer broadleaf forest. The uppermost of the 4 ponds is visible there with the arrow. And just a very beautiful, tranquil place with tremendous access, not just for the tribe, but for public access as well. Unfortunately, these areas, as we've seen in many forested areas throughout the United States and globally as well, are prone to wildfire. And starting in 1998 with the red polygon up to the north there, the Oso fire was superseded in 2000 by the Cerro Grande fire, which made national news, burning Los Alamos National Laboratory and the community there. And then most recently in 2011 with the blue polygon being the 2011 Las Conchas fire, resulted in over 60% of the watershed being burned. All 3 of these fires, it's important to note, started off reservation, encroached onto the reservation, and the tribe is left dealing with the impacts of these. As you can see, we had a stand replacing crown fire, as they refer to it, in the most recent 2011 fire. And pretty much all the vegetation, with the exception of a narrow ribbon of trees there along the canyon bottom, burned. And with that, you can also see the severe erosion and sediment that came down following the fire. And we'll be focusing a lot on that in the evaluation of our crossings. These flood impacts actually exceeded the damages of the fire itself, as far as infrastructure is concerned, at least. It was really a case of cascading disasters where we had multiple wildfires and then even more debris flows and flood events in the years starting in 2011 and proceeding through 2014 with 5 presidential disaster declarations given just for the flood events. These events consumed the creek corridor, the roadway crossings, the recreational structures, fire stations, and produced an enormous amount of debris, both sediment and woody debris from the burned timber, as you can see in that lower left image with the debris dam full of mostly logs there. The image to the right shows a 2019 geologic assessment of sediment that still is prone to coming down in these tributaries. The effects of that sediment are devastating on the infrastructure. These are the aerial reconnaissance of the 4 ponds that were inundated with sediment. The dams subsequently breached, and with that, more flooding and more scour, more debris deposition throughout the canyon. The impacts on the roadway crossings were severe. The lowermost crossing here on New Mexico Highway 30, which is just right in the middle of the Pueblo, above the majority of the village, experienced full capacity. There were originally 6 box culverts there. Those reached full capacity. We had debris accumulating on the guardrail and spilling over the roadway, along with enormous scour on the downstream side, as you can see with the images on the left. The New Mexico Department of Transportation mitigated that situation by adding an additional 2 boxes on the left side there, expanding the wing walls, and installing scour protection with the grade control, those big boulders you can see across there, which transcend to what we'll be getting into as far as nature-based solutions are concerned. And with that, using natural rocks and natural materials that the tribe had readily available became a key strategy that we learned to expand on. The crossing vulnerabilities extend up into the canyon, which we'll be focusing on here in this case study. This is a few examples of a rainfall event we had in 2024. We're talking, 13 years after the fire. We're still seeing impacts from the fire that are being compounded by the amount of debris that is available to be transported through the system. On the left there is a concrete, it's not a low water crossing. It's meant to overtop in a flood event, which it did, but it consisted of 6 36-inch concrete barrels, all at the same elevation. And those subsequently plugged and overtopped, and you can see the structure was compromised on the downstream side. We actually had gone in just a month before this event and had stabilized the downstream side with some big rock structures. And if we hadn't done that, this structure we feel would have been completely compromised and gone. Image on the right just shows one of the dozen or so crossings we have up in the canyon, or had, that were subsequently destroyed this past year, and highlight the need to develop solutions to become resilient to these. There's a total of 63 canyon crossings that consist mostly of culverts, and the majority of those are tributaries that come into the canyon. However, there are over a dozen creek crossings within the stream roadway corridor. We did a culvert inventory in 2016 as part of the FEMA analysis to understand how much infrastructure was there and needed to be maintained. There are 27 culverts in the lower stretch, and I just want to highlight the image on the left there. During that survey, we found we don't know the date, but we estimate in the early 1900s, but a wooden box type culvert that was located under one of these crossings and was still intact and functional. So it's pretty exciting to come across some of those that even some of the cultural resource folks on the tribal staff weren't aware of. Working up into the upper canyon, this was historically an access road located mostly on the north side of the creek, with approximately 6 crossings from what I recall, or from what I understand. This was before my time starting to work with the Pueblo in 2016, but there were very few crossings, and they were rather efficient for transport into the canyon. In addition to that, following the flooding events, a temporary road was completed that extended that to 14 creek crossings, with 20 and an additional 22 tributary culverts. So lots of crossings, lots of culverts, lots of areas to mitigate, and finding a way to do this cost effectively is a big priority of the tribe. But also, how can we do it so we aren't going back and continually having to maintain these things, and how can we integrate resilience? So working with the tribe's priorities of limiting foreign materials, of maximizing and observing the natural processes that are going on, how can we tie into these systems? And one of the ideal strategies that recommendations that the tribe has received is really to eliminate those crossings wherever possible. We'll position that road on the north side again wherever possible. It requires roadway alignment. In some cases can be very costly. In other cases, doesn't necessarily work with where the stream wants to be. The tribe really wants to emphasize letting the creek do what the creek needs to do and adapting the roadway to the stream, which is really contrary to our conventional way of thinking, where we typically just move the stream to where we need it so we can put the road in a certain place. There are instances where that can occur if tribal leadership agrees on it, but the initial priority is to work with the system, not against it. So a second strategy to culvert replacement is with a bridge span. These are great because they maximize conveyance, but they can also be very costly, as we know. Bridges are not cheap. Even the small ones are much more expensive than a culvert. So the cost effectiveness considerations come into play when we look at these numerous culverts and crossings throughout the canyon. And then lastly, upgrading the existing culverts that are there. How can we tie in the grade and the existing floodplains that are there? These can be natural grade controls with rock or boulder, or they can be structural using devices such as, hardened ramps that are made out of steel. But not necessarily great for fish passage, so not an ideal solution. Natural bottom culverts are something we learned about in the late, about 2017 through 19, when we started really looking at culverts. And that's where we really wanted to prioritize fish passage and the natural dynamics of the stream. And this natural bottom became really our first nature-based solution that we started focusing on and integrating with our crossings. We understood we could do this with an arch-type culvert or a box-type culvert when they were set below grade or don't have a bottom on them, or we could actually take our existing culverts and set them below grade and promote an actual natural bottom in a traditional cylindrical CMP culvert. One other recommendation we've received was having an auxiliary perched culvert to convey high waters during those less frequently occurring events. And those perch culverts can also serve as connectivity corridors for small mammals and wildlife as well. Given this area is fairly rural, we don't have a lot of incidents of vehicles being hit by or animals being hit by vehicles. But in areas where you're dealing with paved systems, those perch culverts can provide effective corridors for smaller animals. As we know, culvert types vary tremendously. This is a close-up of that box culvert there on the upper left, as well as some steel options, and in Europe, some stacked stone options that are very elaborate with, homes on top of them. So there's a whole range of styles of culverts you can go in, and aesthetics is a big part of this canyon. They do want to open it again to the public. It is considered a tribal national park to some degree, and they want to do things eloquently, but also cost effectively and resiliently. So looking at the natural bottom culverts, the arch type tend to be the most favored upon. Here are 6 examples, with the lower right example being from one of the structures that we implemented in the canyon. These structures are very effective at maximizing conveyance in a system. They can be less costly than a bridge span. However, they tend to have a very big construction footprint, and still require some channel work and remedying of the natural channel bed to provide effective stream channel and conveyance and fish passage. These are the auxiliary options that we've really learned to evolve with our structures, and primarily the sharing of this overtopping channels with scour protection. This is the only diagram I've come across that actually indicates this concept, and it's not the ideal one, but it is the only one I've found right now until we finish our own Adobe Illustrator project on it. But the concept is very effective in that, one of our famed restoration ecologists who worked in the canyon for 60 years, he says, Garrett, he says, these engineers are going to tell you to build a huge structure, that you're going to get your arch type culverts, but by the time you get halfway down the canyon, you're going to be looking at big structures. And sure enough, we got a third of the way down the canyon, and engineers are promoting 70-foot spans on a stream that averages, a few cubic feet a second a year. And he said it's very important to realize that this creek ran through 48-inch culverts for 60 years with relatively little impacts or headaches for the tribe. So be cognizant of that. And one way I've discovered to do that is, maybe rebuilding some of these culverts similarly as they were, maybe using a horizontal elliptical squash pipe so we can set it below grade, have that natural bottom, but introduce scour protection above, underneath the roadway and below the culvert, so that when these larger events occur during that, less than 5% chance, then there isn't a corridor for that conveyance to be administered through the site, rather than underneath it, you're going over it. And what this does is provides a really cost-effective approach that is really leveraging the power of natural materials for scour protection. You're not putting in concrete head walls or anything. This is just working with the materials we have and providing a cost-effective solution where we can put in crossings for approximately just under $50K a piece, versus arch type culverts that we showed you before that range anywhere from $350 on the low end to $750,000 on a high end. So cost effective, but still really focusing on that floodplain connectivity, that grade, and that natural passage primarily for fish in this case. Another technique we learned about is just the pitch of your head walls. And if you have an inclined head wall, that will actually limit your ability limit clogging within your structure by floating material actually being able to accumulate above it. I talked about ramps to connect grade. Saw a great example of this at this conference yesterday, where they took an old concrete footer from a bridge and just put a rock ramp up to it to remedy the 2-foot barrier that was serving as a barrier for fish migration. And lastly, the perched culverts that I discussed earlier. A few alternative strategies for culverts that are already in place. We see these baffles included on a lot of structures to promote fish passage. And on the left, just adjusting the slope of the culvert can really have significant impacts on fish passage. Looking at this upper canyon, this is our first crossing that we did upgrade as part of a FEMA project within the Pueblo. We took a 48-inch CMP culvert that's, you can't even see the culvert there on the left, but upgraded it to a 21-foot span by 6-foot high arch type culvert integrated with stacked stone. The other thing that we really tried to do with this was incorporate stream restoration above and below and treat the site as a part of a bigger system. And we find that the restoration costs to include 100 or 500 feet of restoration above and below a structure are negligible in comparison to the cost of the structure. And FEMA had no problem with including that. So that was one strategy we've used to really address these sites and really aligned with the indigenous knowledge of working with the system instead of against it. Just an example of the restoration below the crossing here. One best practice we found is just distributing woody debris after. Another nature-based solution, you're using the natural material, you're spreading it out, you're limiting the erosion from the precipitation energy. Woody debris and living willows and alder into the designs. These designs were engineered, stamped, and approved by FEMA, showing that you can actually integrate nature and nature-based solutions into current design standards that need to be approved by benefit cost analysis, as well as federal agencies. Just some examples before and after, integrating the boulders and the root wads down below. Best practices, prioritize stream processes and ecosystem services in your projects, promote natural bottoms, bankful channel integration and floodplain connectivity are key. Integrating restoration above and below your crossings are great. Incline head walls for catching debris, and being considerate of both aquatic and terrestrial connectivity. And then also leveraging indigenous knowledge when possible, limiting the introduction of foreign materials, particularly concrete, with a huge priority for the cultural committee at the tribe in this case, maximizing local natural materials when available, and then incorporating these natural materials as in-kind contributions can be a really cost-effective approach as well. In conclusion, these can provide nature-based solutions, provide a cost-effective, resilient solution to road crossings, treat the crossing as part of the natural system, be cognizant of flood resilience, sediment transport, and wildlife connectivity. And then lastly, working to be inclusive of nature will ensure our transportation corridors minimize negative impacts on the planet. And I'll end with this quote from one of our techs at Santa Clara. If he's out there planting trees and we thought we were doing it for the fish, he says, yeah, it's good for the fish, but he says, if it's ultimately good for the planet, it's good for us too, Garrett. I said, you know what? You're absolutely right, Santiago. I'm going to use your quote from now on. So thank you all. Any questions? And sorry for going over time and the technical issue there.
Oh, that's great, Garrett. We really appreciate it, and what a marvelous way to conclude. I love that quote. I've had some resonant experiences with energy transition work on the Gulf Coast, where there are some groups doing really interesting things with living shorelines, and it's the same spirit that motivates it. Just let the silt do what it wants to do. Right. We'll come back to you. I'm collecting questions, and there are marvelous questions for you from the audience. I do want to turn to Courtney now, and then we'll come back for Q&A after a presentation. Courtney, as I mentioned, is the regional coastal geologist with the National Park Service's Southeast Regional Office, and I'm really excited to have you here, Courtney. Thank you.
Thanks, Jason. Are you seeing my screen?
Yep.
Okay. Thanks, y'all. I'm going to talk today about the kinds of nature-based solutions that we've implemented in parks along the South Atlantic and Gulf Coast, which is the region I work in, and how we've started collaborating with other Department of Interior bureaus to increase awareness and implementation of nature-based solutions. First, as Jason promised, I'll define nature-based solutions from a DOI perspective, which comes from a DOI departmental manual that came out in late 2023. And that manual provides guidance for nature-based solutions delivery and implementation. I'll provide that link at the end. So we define it as actions that incorporate natural features and processes to protect, conserve, restore, use, and manage ecosystems to address challenges while providing measurable co-benefits for both people and for nature. They can be at a local or regional or even global scale, and we prioritize solutions that are likely to remain effective in the long term. So examples I'm showing here include oyster bed restoration and coastal marsh restoration for shoreline protection and fish habitat, and a stormwater management project that improves water quality and also reduces flooding. NBS is really well aligned with the mission of the National Park Service, which is to preserve unimpaired the natural and cultural resources and values for the enjoyment, education, and inspiration of this and future generations. So each NPS unit is created for a unique purpose, which in turn directs the management priorities and strategies for that park. And that mission compels us to consider and provide for human benefit, including at parks that are established to protect specific natural resources, such as a barrier island ecosystem, or cultural resources, such as a historic landscape. And we also need to provide public access to experience and enjoy those resources. And our mission is incorporated throughout park management efforts, including strategies for recreation, visitor communication, resource management, infrastructure, and research, excuse me. Nature-based solutions are already being implemented across the agency through activities like ecosystem restoration, land and water conservation, prescribed fire and fuels treatment. And by implementing NBS in a coordinated and collaborative manner across DOI, we'll be able to optimize the delivery and maximize those co-benefits for people and the environment. And that effort includes engagement with communities and stakeholders to deliver economic benefits, cost effectiveness. I recently learned DOI administers 20% of the nation's lands. So that also ties into an effort to strengthen resilience for disaster and hazard risk management and to support adaptation under changing conditions. And nature-based solutions are selected to be durable and low maintenance. Those natural processes and features are inherently able to handle changing conditions. And this also helps to ensure that the public can continue to access recreational opportunities with less frequent closures due to those maintenance needs. Oh, goodness. Okay. Our Southeast coastal parks are vulnerable to storms, flooding, erosion, and other events. So today I'm going to give you a few coastal examples of nature-based solutions that we're implementing in the southeastern US. These solutions have been developed and refined with knowledge from many disciplines and perspectives. So not just scientists and engineers, but also the maintenance staff who repair the flooded facilities, the administrative staff who identify opportunities to leverage funding and investments, and the visitor services staff who interpret park resources for the public. We at NPS were focusing more recently on intentional nature-based solution design. This is an ongoing process for awareness and implementation, but I will say we just historically have done a lot of nature-based solutions, not nature-based solution aligned projects just by the nature of our mission. So I mentioned that nature-based solutions provide multiple co-benefits of society and environment. And here's an example from Jean Lafitte National Historic Park and Preserve. This is my closest park here in Louisiana. Relict canals from before the park were established were created for navigation, drainage, oil exploration. And now we're backfilling almost 13 miles of that. And this provides natural resources benefits you can see in this table, such as restoring hydrology, increasing habitat and biodiversity. And it also provides the adjacent communities better flood protection, recreation, and subsistence fishing. It's a big part of the culture here. Some of our barrier island parks have roads that are very important for providing visitor access and also as emergency evacuation routes. And these islands can be very low and frequently overwashed during storms. That overwash is an important part of creating and maintaining habitat, including for protected species. And NPS management policies compel us to preserve natural processes also, except in a few cases such as human safety or protection of archaeological resources, for example. So all the parks I'm showing here have been impacted historically by human actions like dredging, inlet maintenance, construction, other kinds of sediment management. At Canaveral National Seashore on the east coast of Florida, and at Gulf Islands National Seashore on the Gulf Coast, and Cape Hatteras National Seashore in North Carolina. These are 3 photos from those parks. The sand, they have a road, each of them down a narrow island that's frequently overwashed, and that sand needs to be cleared, but we don't want to put it just anywhere. So when we move it off the road, we want to make sure it doesn't degrade existing habitat, like can't put it on top of the adjacent wetlands or bird foraging areas. We want to make sure it doesn't leave the island even more vulnerable to overwash and breaching. And if it's during nesting season, we need to look out for birds and turtles and nests. So these 3 parks are in sort of different stages here. Canaveral National Seashore on the left has temporary methods. They push the sand off of the road and back towards the beach. So they create a road parallel sort of dune structure. It's a lot of maintenance after each storm, which can be several times a year with many feet of sand on the road. And so they're currently entering a 3-year planning process that'll take a bigger picture approach to evaluate visitor facilities and transportation through the whole park. Gulf Islands National Seashore in the middle has developed a sand management plan. That was an EA, an environmental assessment. And that identifies how and where sand can be moved and how wildlife monitoring must occur when that's happening. And then on the right at Cape Hatteras, they've developed a 20-year sediment management plan. That was an EIS, environmental impact statement. And that describes what circumstances would allow for nourishment and breach filling and where. And this was developed with many stakeholders, so it's already in place when the next disaster occurs. Some parks have created alternatives to roads. In North Carolina, visitors can use ferries and rent ATVs or take a beach shuttle to experience Cape Lookout National Seashore. That's the 2 photos on the left. And at Pea Island National Wildlife Refuge, it's a Fish and Wildlife Service area on the right. You can see in this aerial photo, there's a very narrow portion of the island that's an evacuation route and often overwashes. So eventually, a portion of it was bypassed with a new causeway on the sound side of the most vulnerable portion. That, as you might expect, was fairly expensive. That's about 2.5 miles for $145 million. Sometimes the solution has been to accept that the dynamic natural processes will or should continue and to build to accommodate those changes. These 2 photos are from Assateague Island National Seashore in Virginia. This also occurs in Maryland. These photos are from Virginia, where parking lots are often overwashed during storms. So on the left, the vault toilet is mounted on a wooden deck to allow for easy relocation in advance of storms. And the pipe underneath can be capped and then relocated, excavated from the overwash deposits and reconnected. On the right, you see a parking lot. Storms used to break apart and then deposit the asphalt from conventional parking lots and put that asphalt on the beaches. So the park replaced some of those lots with a clay sand mix and clamshells, which are materials natural to the area, so that when that gets broken up and goes onto the beach, it's aesthetically and environmentally less concerning. It does require regular maintenance, about weekly, to brush off the sand, because these are just normal cars driving and parking on this. These are not necessarily off-road vehicles that are prepared for sand. And that the park is also now implementing a longer term solution. It's taken a while, for design and funding, but they've started constructing a parking lot a bit north of here in a wider area that's behind the dunes. So it's expected to last longer. This photo is also from Assateague Island. These are temporary solutions to provide time to design and fund longer term solutions. This is a parking lot along the Bayside shoreline on the Maryland portion of the park. And this solution was developed by University of Virginia landscape architects. They've placed trees in these, you can see the crosshatched area in the middle. And on the right is an a photo of on the ground what it looks like. So burying trees at this angle, trunks. And the intent is to just slow down that erosion, which is happening very rapidly there. So those are some examples from the Park Service. I also want to talk about our collaboration across the Department of Interior. We've created a community of practice across DOI, and next week NPS will be launching a smaller just NPS community next week. And in both cases, we think our success is due to welcoming all disciplines and experience levels. I mentioned earlier that it takes all sorts of job roles and experiences to implement this on the ground. And the intent is to share knowledge across all of those disciplines and bureaus, and to collaborate to develop and implement processes and solutions. And it really inspire that landscape level conservation. And part of that is creating and sustaining connections. So we've set up Teams channels for just an informal exchange. Anytime you can post meeting announcements, interesting articles, questions. Has anyone dealt with this problem before? And then we also have more formal monthly or quarterly, depending, meetings that have usually a presentation and then discussion about that, and then a broader, just sort of open mic opportunity to discuss. Additionally, there's a smaller NPS team that works with a larger DOI effort to implement and educate about nature-based solutions. And right now we're working on developing metrics to evaluate project performance. But I'm going to show you something we just launched a few months ago in a few slides. But I also wanted to offer these resources. I'll paste these links for the host to share later. These are several online resources available to help you identify nature-based solutions that might fit your needs. Case studies, toolboxes, things like that. So this is the new tool we launched a few months ago. This was a collaboration between Department of Interior and Duke's Nicholas Institute. And I'll run you through a quick demo and say we're continuing to add to it. We'll be adding those tool links. So this is the landing page. And you can select strategies, nature-based solution strategies, to learn more about them, or search by habitat. You can also search for case studies, which will also have information on how to contact people if you have more information. There's a drop-down menu, and for example, you can choose protect infrastructure, or you can start typing that, and that provides a list of case studies that match your goal. And when you select a case study, you'll get links to more information, linked tools and strategies, and then you can also click on the original source. Okay, you're probably familiar with this diagram: green, hybrid, gray infrastructure techniques. So green techniques tend to provide multiple benefits for people and ecosystems, like recreation and habitat. And gray techniques tend to be focused on one purpose, such as erosion. The roadmap is intended to help DOI staff to identify solutions that, or not just DOI, all of you, to fit their situation or project. And I want to acknowledge that not all problems are well suited to green infrastructure or hybrid infrastructure. This table, also available on the roadmap, helps to bridge that gap between gray and green. So if you're thinking about, a bulkhead, here's some other things you might think about. Sometimes nature-based solutions can independently achieve project goals. Sometimes you'll need a hybrid approach or just gray. Recognize I'm near the end of time, so I will just turn this back to Jason and happy to answer questions.
Thank you so much, Courtney. Really a super helpful presentation and a marvelous collection of helpful resources. I think we'll be very glad to send those out to the whole audience. One of the things that was striking to me about your work, from the perspective of a social scientist, is that it sounds like your efforts did focus actually quite a bit on, who was doing the work of, implementing the nature-based solutions in different contexts. And I really like the way that you framed that in terms of communities of practice. Especially inside a pretty big organization, doing the work of supporting that is very helpful and important. I think sometimes it's easy to look over the social side of these things, so it's just marvelous. Christine will be transitioning us soon to the grid view to Q&A. So if you guys wouldn't mind turning on your cameras and unmuting so we can all be seen, I'll go ahead and pass on a few of the questions. I should say we're very fortunate today to have had an incredibly engaged audience. There, are already 13 question and answer exchanges, which is just marvelous, and a few other open things. One thing that I wanted to maybe give everyone an opportunity to answer in your own way, if you choose to, and it's one of those questions that can be a little bit awkward. But given that there has been quite a change in the political context over the past year or so, I wonder how you, from your perspective, are thinking about that. As you plan these projects, you have a reprioritization going on from the federal level, and yet, as I think about it anyway, whether you call it climate change or not, and whether you focus on mitigation or resilience, and whether you believe climate change is happening because of one thing or another thing, transportation systems still face very real risks from materials, substances, and risks in the real world, like heat and water. These specific things are not going away. So, I'm curious how you think about your work in the current context.
I can answer part of that. As I mentioned earlier, we're very lucky at the Park Service. Our mission is so aligned with social, recreational, natural, and cultural benefits that that reduces the conflict, obviously. But we are very aware of we've been talking about the ways that our work can assist the changing priorities, which include things like risk reduction for wildfires and the energy grid and flooding and water availability. I mean, those things are going to be important to all sorts of people and regions of the country. And but in addition to the changes, I forgot to mention on that roadmap, it's hosted on a Duke website, and they've downloaded PDFs of those links to archive, so when you click on it, you'll get a PDF archived version, because so that future links aren't broken, and it'll continue to be useful.
Maybe I'll add, can you hear me?
Yep.
I'll add just very quickly that initially, I indicated that the driving rationale of the climate risk assessment was to prioritize projects in the capital plan, identify needs, develop scoping level mitigation measures, ensure they're prioritized in the capital plan. A paired objective initially was to also develop a grants pipeline, a robust grants pipeline for FEMA and DOT in particular. And I'm not saying that won't happen, but it's clearly a shelved objective at this point in time, given the uncertainty around those programs. I'll also say our messaging to senior management has been, look, it's more important that we do this work than it's ever been before. The federal tailwind has become a headwind. So it's incumbent on us at the state, local, and regional level to step up and to do more. So our response should not be to hide our head in the sand, but to put our foot on the accelerator and do our best to try to fill the gap.
Yeah, and I'll just also add to that it's always been a pretty volatile state in terms of, when the federal government's being more progressive, there are always a lot of states that aren't. And so from the get-go, when we started to design this very intensive climate risk assessment, and we started developing out these very detailed standard operating procedures, really for consistency across our own facilities, so that we could compare apples to apples, different risks and mitigation measures for prioritization. We wanted to make sure that we were getting this methodology out into the world, and we weren't just, doing it for ourselves, but moving the practice forward for others as well. So that was a goal for our group from the very beginning. And, no matter kind of what the political climate is, we just are trying to get those resources out there so that others can take this on themselves, even when funding is more or less available from external sources.
Jason, I'll just add, I think being cognizant of your terminology, and we've been, shifting our focus away from using buzzwords like climate. We were already, as the tribe, just to prevent future potential of this occurring, we use climate. What do we use? Climate adaptation, or sorry, what was it? We weren't using climate change. We were using climate variability. Just a little shift of language, just in case that with these reports we did a couple years ago, if for some reason they get targeted in the future. But then the other thing is looking for opportunities where we can highlight like effectiveness or cost effectiveness in the case of the infrastructure work we're doing with FEMA still, and showing that there is a great deal of efficiency that can be gained when incorporating nature-based solutions. I think those are opportunities we see developing in the next couple of years and with this administration, and being able to highlight the objectives of the administration that do occur within these projects. As Courtney said, the nature-based solutions are multi-benefit, and those extend not just ecologically, but I think socially and from financially as well.
Thank you all for the thoughtful answers. I really appreciate those. It makes me think. I'm glad you brought up the importance of framing and the words we use to talk about these things, Garrett. I have noticed a similar thing in a research project that I did that was about energy transition, and we interviewed people in lots of different communities with lots of different priorities from lots of different occupations. And one thing that we noticed was that when we would use certain words, the conversation would go off the rails. And what we decided to do was to make that a research finding. And so, we published a table of, we called them trigger words. And said, if you're talking with, this community of people, this word may trigger this kind of response. This other community of people, this word might trigger this kind of response. And our recommendation to folks was to try to ratchet down and specify the level at which you're talking about something. So maybe instead of climate change as a buzzword, to use Garrett's language, you talk about climate vulnerability, right? Or even more specifically, heat and water. In the case of the energy transition project, rather than saying fossil fuels, which can be politicized pretty quickly, you can speak about coal, oil, and gas. These are harder to argue over. And then that way, if you're just speaking about one of those energy sources, you can be very specific and precise about what it is that you're getting at. So it's better for exchange, I would think. So in response to a couple of the questions in the chat, one of the questions is, will these presentations be available to view later? They absolutely are going to be. We'll post them to the Harvard and Salata YouTube channel. And the trigger word list I mentioned that's from the Energy Transition Project, that you can find on my website. That's a whole different project. It's in this thing called the Gulf Coast Case Study. But let me go ahead and sum up, since we're running close to the final time. And I did want to mention just a few things at the by way of conclusion. And sorry, I think I made a mistake on sharing my screen. You all did this so beautifully, and this worked just fine for me before. Let me see. Okay. So looking ahead, as I mentioned, we will post this webinar. The next webinar will actually be on May 28th, same time, 2 Eastern time. The topic that day is energy transition technology in transportation rights of way. So using transportation rights of way for energy transmission and generation and storage. If you see this, online, and you want to sign up for the list of announcements of these webinars, you can email the Salata Institute at their general email address. And I wanted to mention too that we have several webinars planned coming up in the future, and we are looking for speakers, for a few of these. And so if you have names that come to mind, I'm certainly welcoming of suggestions. We'll have one on mobility and accessibility and equity. We'll have one on pricing. We'll have one on public transportation ridership, changes, composition. We'll have one on sustainable freight. And we'll have one on resilience lessons from disasters. What can we learn about transportation system resilience from systems that have experienced and managed to recover from very serious natural hazards and natural disasters? So with that, I want to conclude and thank all the participants for joining in the audience. It was wonderful to have such an active audience today. And really to the presenters, I want to thank you all for very thoughtful, very careful, and I think very helpful presentations. And so I really hope everyone makes the most of these resources that you have very generously offered to us.